In this example, let's find what is the following volume. Consider the solid with base given by the region between the functions f of x equals cosine x, g of x equals sine of x, and between x equals negative 3 pi over 4 and x equals pi over 4. So the base of this volume is going to be given by the intersection of these curves and with cross sections perpendicular to the x-axis, and the shapes are going to be semicircles. So let me try to describe this region and then find what is the volume that we're looking for. So I'll try to avoid using any calculators or any visualization right now, so we can actually sketch what this solid looks like without the need of a calculator. So there are two important things to notice in here. The first thing is the base. What is the shape of the base? And the second is the cross section. With that information, we can figure out what is the volume of this solid. So let me start first with the base. The base is going to be the region between negative 3 pi over 4 and pi over 4. So we have that the region is bounded by these two vertical lines, and between the graphs of cosine and sine. So this is going to look a little bit like this. So we have the graph of sine and cosine. They follow each other. And then at negative 3 pi over 4 and pi over 4, they intersect. In other words, the shape of the base, or the floor for this solid, is going to be the area between these two functions. So we have that the top function is cosine of x, the bottom function is sine of x. So again, the important thing in here is basically just to have a reference to the base of that solid. And what we need to know now is that the cross sections are going to be semicircles. In other words, the cross sections are going to be perpendicular to the cross axis, to the x-axis. So that means that this is going to be a typical cross section, and that cross section is going to look like a semicircle. In other words, what we're going to do is we're going to have a collection of semicircles going perpendicular to the x-axis. So now we can pursue the strategy that we had before. We want to find the shape of the cross section. We want to find the volume by finding the area of this cross section. And then finally, we just write down the integral corresponding to this volume. So the cross section that we're looking for right now, as we mentioned, these are semicircles. And because we are talking about semicircles, which means half of a circle, that means that the area we're looking for is not pi r squared, but actually pi r squared divided by 2. So what we have is that the shape of the cross sections define what is the area that I need to use. So right now what we need to do is we need to rewrite r in terms of x. That way we can actually come up with the integral representing this volume. So in this case, what we need to figure out is that the radius for the semicircle, that's the quantity that we're looking for, is going to be half of the diameter. And basically the diameter is just the length of the top part minus the bottom part. And this is a trick that we've been looking for a couple times now. In other words, we need to find what is the top part minus the bottom part of this, and that will give me the diameter. So in other words, I would get that r is just the diameter divided by 2. So finding the diameter is a quick way to find the radius for this. From the picture, we have that the top part is given to me by the cosine, and the bottom part is given to me by sine. So we can find that the length of that segment, or the diameter, is actually going to be cosine of x minus sine of x. That's the length of the full thing. In other words, if I put these two equations together, this one and this one, I actually get that the radius I'm looking for is going to be cosine of x minus sine of x divided by 2. So now I can actually put everything together, and I have that the area of this semicircle in terms of x is going to be pi r squared divided by 2, but we now know how to write down r in terms of x. So this would be cosine of x minus sine of x divided by 2, whole thing squared, and then I divide it by 2. Okay? So let me try to simplify this a little bit so we have a nicer expression. So this will become, I can take this 2 square outside, that becomes a 4, and then with this other 2, that becomes an 8. So I have pi over 8 cosine x squared minus sine whole thing squared. And now I can just expand this expression, and this will become pi over 8 cosine square x minus 2 times cosine x sine of x plus sine square x. Now we actually can use a common trig identity, that is sine square plus cosine square. I can replace that by a common number. We have that will be pi over 8, and then these two I'll replace by 1. Cosine square plus sine square equals 1. So it will be 1 minus 2 times cosine of x sine of x. So we have that is the area of the cross sections. Now, in order to find the volume, in order to find the last part, I want to write down the integral corresponding to this volume. So this should be just the volume to be the integral between negative 3 pi over 4 to pi over 4 of the area of the cross section dx, which in this case would be the integral between negative 3 pi over 4 to pi over 4 of pi over 8, 1 minus 2 times cosine x sine of x dx. Now this is an integral that I can work, so let me actually work it out. I will first bring the pi over 8 as a constant in front of everything, so I'll get pi over 8 integral negative 3 pi over 4 to pi over 4, 1 minus 2 times cosine x sine of x dx. Now I can split that integral actually into two integrals. So I'll get pi over 8 integral from negative 3 pi over 4 to pi over 4 of 1 dx minus pi over 8 integral negative 3 pi over 4 to pi over 4 to cosine sine x dx. So notice that the only thing that I did was to split this integral into two terms, and the main reason for that is because the first integral is pretty straightforward. We have that the first part is going to be just x, so that I can work it out. But the second part, I will need to do a u substitution. So let me work out the first part. The first part will be just pi over 8 x between negative 3 pi over 4 and pi over 4. Now for the second integral, I need to do a u substitution. So the substitution I'm going to do is I'm going to make u equals sine of x. And in this case I chose this one because du is cosine x dx. And notice that I have that over here. So I can easily rewrite that expression. So this will be minus pi over 8, the integral of 2 times u du. So that integral transforms very nicely. Now, in order to find the limits of integration, I just have to set x equals negative pi over 4 and x equals pi over 8 over 4 up here, and find the corresponding values for u. So whenever x equals negative pi over 4 and I compute sine of that, that will give me negative 1 over square root of 2. And whenever I plug pi over 4 for x, that will give me positive 1 over square root of 2. Remember also that 1 over square root of 2 is the same thing as square root of 2 over 2. So either of those will work. Now I can work out the last integral. So this will become pi over 8. And this will be pi over 4 minus negative 3 pi over 4 minus pi over 8 times u squared between negative 1 over square root of 2 and positive 1 over square root of 2. All right, so now I can just expand this out. So I'll get pi over 8, pi over 4 plus 3 pi over 4 from the first one, minus pi over 8, and then this will become 1 over square root of 2 squared minus negative 1 over square root of 2 squared. So I'm almost done. I just have to simplify this expression. For the first part, I will get pi over 4 plus 3 pi over 4. That will give me pi over 4. That will give me 4 pi over 4. So this will become pi over 8 times 4 pi over 4, which is the same thing as pi. So I can just erase that. Minus pi over 8. And this will be 1/2 minus 1/2. So in the end, this actually will be 0. So that disappears. And in the end, I will get just pi squared over 8 as my answer. So the only thing that I did was to describe the region that I have right here, then to describe the cross section that I have right here. And with that, I was able to come up with the integral representation. In the end, we have pi squared over 8.